formulas should be more straightforward than some of the things we do, particularly with the circles. They usually get these. Alright, so first thing, hopefully for now you have some kind of basic idea of what area is. Like not how to find it, not asking that, but a general idea of if I say find the area of something, you understand what you're actually looking for. Not how to find it, but what you're looking for. Okay? And if I say give me some kind of basic definition of area, what might you say? What do you mean by the area? You're using the word in the definition. That's not bad. If you use the word space, you're talking about freezing. So if you look at it, like stuff, the massive volume. These are all volume ones. That's okay. I know what you mean when you say the space inside something. Just kind of, by definition, right? Area is the total number of square units that fit inside a given shape. And by shape, we're talking about flat shape. This is all the two-dimensional stuff. Everything is flat. So if you talk about like painting a wall, that's if you need to find like how much paint you needed for a wall, that would be area. Okay? Or how much flooring to put down, that'd be area. So it's all flat measure. And I bring it up in the manner of what it says up there, just to remind you, square units. When you do area that very first time when they introduce it, they'll give you like a shape, right? And they draw like little squares in it. You count up the number of squares, and that is the areas, whatever squares, however many were there in the shape. We're really not going to be doing that in here because you'll be doing shapes that are not necessarily conducive to having squares put in them. Okay, even today, like kites and rhombus and stuff, they can't really just fill them with squares. We do have ones that are cut in half or cut in quarters and things like that. Other things you gotta know, make sure you get units down. When we do units for area stuff, it's always the unit with a little squared after it. We're talking about square centimeters, square inches, square yards, square feet, square whatever the unit is. And also, like, if we're doing perimeter, right, you just don't put the squared after it. Perimeters are just centimeters, inches, yards. Okay, and I'm bringing this up because, guys, you're going to have to make sure you're putting units on your problem. On the test, for this stuff, if the units aren't there, I will take points off. Get in the habit of writing units out, if they exist. Okay? So if the problem doesn't have units, I'm probably not too worried about you putting like the word square units afterwards for the term. This is mostly if the problem has units. Okay? Alright, so first shape you guys are working with today is parallelogram. Alright, we just have all that up there. If you know how to find area of a rectangle, you know how to find the area of a parallelogram. It's exactly the same. For this switch here between what you would normally do is if I said, tell me what you do to find the area of a rectangle, most people would say length times width. Right now, as of right now, we reference it as base times height because of all the different things that can stem off of it. Okay, because if I took like a rectangle and just slanted it sideways, that would create a parallelogram because a rectangle is a parallelogram. All right, and base and height look a little better on a parallelogram than saying length times width, because I really don't know what I'd be talking about if I said length and width of a parallelogram. But I understand base of a parallelogram would be one of the sides. Okay, and the height would be the distance between whatever side I'm calling the base. Okay, so just kind of keep that in mind. And also, you use base and height because it ties into a triangle, okay, also. Right? And I talked about that way back in chapter 1. You know, if you got a rectangle, base times height, you cut it in half to create a triangle. That makes the area formula for a triangle, which will be up there in a second in case you forgot it. Okay, so, and guys, the base times height thing works for any shape It's a parallelogram. That means rectangle, square, rhombus, or just a basic parallelogram. Since they're all technically parallelograms, you can use that formula. Okay? All right. Can I go past this? All right. So, the types of problems you'll see. These will be your easier ones. Okay? Where they're giving you the height, they're giving you the base, you set them multiply them together. Right? The reason, like the one on the left, should not be that big of a deal to work out. Okay? The thing you got to make sure you're looking for here is understanding that the height and the base always make a right angle. Alright, so when you're picking those two out, make sure you find the right angle. That'd be the height, that'd be the base. Okay, so when I actually work it out, this one right here just becomes what? What will be the area of that one? 20. 20. Alright, this one is just 20 because it's 4 times 5. Alright, and again, I've got units up there. Make sure you throw the units on them. Okay? What about the one on the right? What do you think the area for that is? Or what two numbers am I multiplying together to get the area? 3.5 and 2. I try and show you examples with these because the dashed lines sometimes throw people off. Guys, this dashed line here is just extended to show you that this height is perpendicular with this base. Right? You never include the dashed lines. Like for the base, you don't like find this number right here and then add them together. This isn't technically any part of the base bit. When they put the dashed lines there, when they do it with triangles also, it's just to show you that line right there, the 3.5 is perpendicular to that side. Okay? 3.5 times 2 is what? So this is 7%. Okay? So like basic problems like that aren't that big a deal. It's just you find the two numbers, multiply. Okay? Now, building on that. The next guy. This is another problem that they'll give you based on an area formula. Okay? So the problem says for parallelogram ABCD, what is the measure of DE, the nearest 10? Okay? So DE is right here. So what they're asking to find is that side. Okay? And since if I'm looking at this, I would see that that's perpendicular to that side. So I know this is technically a height at the base. Correct? So I could do something where I go, area of that shape equals 9.4 times x. Correct? Like if I knew what this value is and I multiplied those two together, that would give me the area, right? Okay. I can solve that equation out as long as I can figure out what the area is. What would be the area of that shape?
9 times 13.
Okay. And why are you allowed to do the 9 times 13? Are they bases in height?
Yeah.
Yeah. How do you know they're bases in height together? What do they make? What kind of angle do they make between them?
9.
Yeah. As soon as you see that right angle, guys, these two can be used for bases in height. Alright? Usually with this one, it's hard for people to see unless you turn it sideways, because then if you turn it sideways, you can see that's going directly up and down. Alright? Which would then create a height. So what all you're doing is you're taking the whole idea that area equals, what do we have, 9.4 times x. That was my DE right there. And then over here, we did the same thing. But over here, the point of doing 9 times 13 is to get an actual numerical value. Like, what's 9 times 13? Let's say 117. So then you can take that 117, plug it in right there. Okay? So then solving that out, all I gotta do is divide it over. So what's 117 divided by 9.4? 4. And that'd be your answer there. Okay, so if you see something like this, this is basically allowing you, or having you utilize the area formulas in knowing areas of the shape, you know, just looking at it in different fashions. Okay? All right. And that's probably the hardest kind of thing they can give you with a parallelogram. There isn't much else you can do with a parallelogram in terms of like problem-wise, what I could have. Okay? Next thing. All right, so with the triangle, we've already done this before, right? Areas half based on site. All right, so if you take a rectangle, which is based on site, cut it in half, or a parallelogram and cut it directly in half, like with a diagonal. You just take the area formula we just had and cut it in half, which was based on site times 1/2. Everything's half. The biggest thing with these, and when we did this before, I mentioned it, or I didn't really point out big then, because I knew we were doing it later. But wherever the right angle is formed, that's the base and height that you use. Even if it doesn't look like a height, it's turned sideways, whatever. As soon as you see that right angle, those are the two numbers you're plugging in for the B and A. Okay, even if it's on the outside. I bring that up particularly because with right triangles, if you've got all the sides of a right triangle, you have the base and height. Okay? Like when we do the one in the middle, I don't have to add any other lines to it. I've got my numbers right there. I think actually in all these. Okay, so if I work through all these, this first one here, what would be the base that I use? 7, right? Because I got to go all the way across, so 4 plus 3 would give me the 7. And what's the height? 4. So that area is how much? 14. What's the units? All right, what about this one? What numbers am I going to use? 4.5 and 6. 4.5 and 6. Okay, and I'm using that because those are the two that form the right angle. That's what I'm looking for. So what is 1/2 4.5 times 6? 13.5? Okay. That's square yard. Alright, and then over here, what numbers am I going to be using for my base and height? 2 and 3. They're going to put that 2 there because someone's going to go with the entire side being 4. Remember, just making sure that dash line, guys, you never include. Okay? They're putting that there to throw you off. See if you actually understand what part is the base. This part right here is the only thing that's on the actual triangle. So that area is just 3 feet square feet. Okay? So I'm trying to point out like common mistakes with the examples. Like never include this part. It's dash. With the right triangles, guys, if you've got the two sides that make the right angle, you don't need to add that line. Alright, there's a lot of people that try and add that line in there, and they waste extra time figuring out what the length of it is, and they don't need to. Okay? Gotta keep those in mind. Alright? Otherwise, the area of the triangle stuff should be pretty straightforward. Okay? Next one, trapezoid. Okay, so when we did trapezoid, I kept bringing up stuff about trapezoids, you know, and triangles being extremely similar, right? And I said essentially if you just took a triangle, cut off the top of it, you're creating a trapezoid. As long as where you cut it, you know, is parallel to the bottom part. Okay, which means that since trapezoids and triangles are about the same, that means the formulas used are about the same. Alright? The only difference between them was trapezoids you have 2 bases instead of the 1. Okay? So basically you add the bases together. It's still 1/2 base times height. Okay, but since you have two bases in a trapezoid, you have to add them to account for the entire base measurement. But in essence, it's the same formula used for the triangle, half base times height. Okay, so even problems with this aren't necessarily going to be that hard. With these, there's going to be sometimes more work to do because wherever that height's drawn in, most of the time they're going to attach it here. They attach it here. You got a right triangle right there. So that means that everything we just did right in that last chapter, where I said you better make sure you can do all that stuff because it's going to come back every chapter after. Right triangle, they can ask you to find side lengths of the right triangle. You can be using Pythagorean theorem with it, sine, cosine, tangent, anything. Okay, the trapezoids, that's like a notorious kind of problem. So they're going to do that. It's always going to show up. Okay, so here be types of problems you'll see with these. All right, all of them same formula, right? They're all trapezoids. So for every single one of these, you're just doing 1/2 the height times base 1 plus base 2. So you just got to make sure you have all three measurements. As long as you have all three measurements, it shouldn't be an issue, problem. Okay. Obviously, I've got it in terms of from left to right, least amount of work to most work. Okay, so we'll do the one on the left first, because everything's on this one, right? Do I have both base measurements? Yeah. Do I have a height? Yeah. So this one should be just, you recognize I have both of, or all three measurements. I just have to plug them in. 21 plus 38. So 1/2 60 would be 8 times 59. That's those are added together. So what's 8 times 59? For what? 72. Okay. So and that's just one where you see all three measurements. There isn't anything else to do to find them. And then you just plug them in. All right. The next one over here. Okay. The one in the middle. Do I have all three of the measurements right now? No. What do I have in terms of like the two bases and the height? Just flat up what I'm looking at. I've got which one? I got one base or two bases? Two? How? Okay, so yeah, so pretty much from the start you've got one base there and then one base here, which is 9. Okay? So if I was doing the area there, like I can start that area formula as 1/2. Those two added together. I just need to find the height right here. So like I said, it's a right triangle. You got two sides of a right triangle. What do you use to find the third side? Pythagorean theorem. Okay, so that's going to be my height. So with this one, it's going to be like 8 squared plus 5 squared. Or you can just remember it's a 3, 4, 5 right triangle. It's a pretty common one. 3, 4, 5, 6, 8, 10. Okay, but if you forgot that, you do Pythagorean theorem, you solve that, you will get the height being 4. Okay, so this one we go 1/2 of the height. I know I wrote it a little differently. I was just plugging in what I knew as I went. So 1/2 of 4 is 2 times 15. What's 2 times 15? 30. So this is 30. Okay, now the last one here is it's pretty much the same as the middle one. The difference with this is the height's not technically drawn in, so draw it in. If the height's missing on any of these, draw them in such a way that you create a right triangle. Okay? So that when I actually do the work for this, I'm really focusing on solving this right triangle first. And then once I've got that triangle worked out fully, then I can go back and find everything else out. Now, what you should be doing, what you should notice is they give you the 60 degrees there for a reason, right? Because if you've got 60 degrees in the triangle, it's a 30, 60, 90 right triangle. 30, 60, 90s and 45, 45, 90s are going to come up because you can do them pretty quick with those ratios. You don't actually need like sine, cosine, tangent. Now, if you use sine, cosine, tangent in this case, you still get the same answer. All right, I'm not worried about answers being in simplest radical form for these. I more just want you to be able to get the correct answer. Probably like rounded to the nearest tenth at the end. Okay? So I don't really care how you would go about it, but no matter how you go about it, you're pretty much stuck with this triangle, finding this side here, the h, the height, and finding that side right there. Okay? If I do it with 30, 60, 90s, remember this is the longest side, so the shortest side right here is just half of that. So if that's 8, this is 4. Okay? So I know from there to there is 4 now. All right, and if from here to here is 4, can you figure out what the top base is now? Yeah. 11. Is that okay? Right, the entire thing's 15. Take that 4 away, I've got whatever the top was. All right. Once I know this is 4, what do you want to do to find the other side? Yeah, if you remember the ratios, guys, remember you can just multiply by square root of 3. That's fine. If not, if you forgot those, or if you just remember the one that's where it's the longest, you cut it in half to get the shortest, you could have done that. Got all those. If you just wanted to do it from the beginning, finding the height, I could have done like sine of 60 with h over 8. Doesn't matter. Okay? Whichever way you're doing it, you have all those things from last chapter to use. Utilize all of them. Whichever one you're the most comfortable with. Okay? So once I do all that, so 4 square root of 3, I'll leave this with the square root. So I have it there. So here I have area is 1/2 the height times 11 plus 15. Right? That's base plus base. Which comes down to 2 square root of 3 times 6. 26 times 2 is 52. So 52 square root of 3 squared. That would be your answer. And like I said, if you do this with decimals, that's fine. I'm not going to probably, I'm pretty sure I will not ask you guys to leave that many simple radicals. I'm not going to guarantee it. Okay? All right. Last shape you guys are dealing with today is this one. I know there's 2 words up there. But the reason I group these together is they have the same area for them. All right? And with the rhombus, this is just an alternate way to find a rhombus. The formula you had for parallelogram also applies to a rhombus. So if I give you a rhombus and I give you the base and the height, you don't need to use this formula. Okay? The rhombus is a parallelogram, the other one applies. And also, guys, since a square is a rhombus, this formula right here also works for a square. Okay? All right, so D1 and D2 just mean the length of the diagonal. So you do the length of one diagonal, multiply by the other one, cut it in half. Okay? This also works for the majority of your quadrilaterals as well. Okay? So you take whatever the lengths of the diagonals are, multiply them together and divide it by 2. Now, with these, also remember, the diagonals of a rhombus make right angles in there. Meaning you've got 4 right triangles you can work with. Pythagorean theorem is going to come up. You might do stuff with sine, cosine, tangent. Same thing in a kite. Diagonals are perpendicular. There's 4 right triangles there. Everything you did in the last chapter still applies to these. Okay? But the S infinite, most of these formulas today are pretty easy and straightforward. Alright? Can we go past this? Alright, so these would be, I'm not going to go through all of them, I'm just going to pick a couple. We'll do like, let's do 21 on the top. Alright, so just to show you where the numbers are coming from and what I mean by diagonals, right? When I say 1/2 d1 times d2, what I'm saying is find the length of this diagonal, what's the length of that diagonal right there in 21? How much is it? It's 6, right? 2 and 4 together. What's the length of the other one? Still 6, right? 2 plus 3, still 6. So for 21, it's just going to be 1/2 6 times 6, which is what? What is it? 8? 18? 18. Okay? Alright, and then take one of the ones at the bottom. Right there.
Number 24.
24?
Yes.
Okay. Alright, so on 24, this would be one where you go O to rhombus. They're telling you this part's 8, that part's 10. Which means, based on what I have there before I do any other work, the only other measurements I can put in is, these are all 10, and that's 8, right? Because diagonals bisect each other in a rhombus. So basically, the only thing I have in terms of this formula right now is I've got one of the diagonals all the way across, right? I've got 8 and 8, which is 16. So I've got, essentially, area is 1/2 16 times d2, which I don't know yet. But I already told you, just reminded you, there's the right angles in there. Right triangle. So if I find then 8, that side right there, that's going to become from that side. Okay? What do I do to find that side? We got 2 of the sides. How do I find the third? Pythagorean theorem. Got 2 sides, find the third, Pythagorean theorem. That should be something ingrained in your head. Okay? I'll tell you on the test, a lot of people overthought these problems. Get way too much stuff. Yeah. So this would be x squared plus 8 squared equals 10 squared. Solve that out, you will get 6. Alright, which again means if this part's 6, that part is also 6. So that diagonal 2 would become what? So 1/2 of 16 times 12 is what? Is it? 96.